All right, let's talk about what might just be the single most important technique for making AI truly reliable. It's called Retrieval Augmented Generation, or as everyone calls it, RAG. This is the tech that transforms a super creative but sometimes, let's say, forgetful large language model into a genuine, fact-based expert. How? By giving it an open book exam.
This quote right here really nails it. We get so caught up in making AI models bigger and bigger, thinking that's what makes them smarter. But here's the thing. In the real world, all that raw intelligence is pretty much useless if it can't get to the right facts at the right time. RAG is the system that fixes this feeding problem, making sure that an AI isn't just smart, but it's also correct.
So, what's the problem we're actually trying to solve here? Well, a standard large language model is basically like a student taking a really tough exam from memory. A closed book exam. It only knows what it memorized during its training. I've also heard it described as an overenthusiastic new employee who just confidently answers everything, even if it has to make stuff up. And that is what we call hallucination. It's the #1 reason we hesitate to trust AI with important jobs.
And this is where RAG just completely changes the game. It gives the model that open book. So instead of only using its internal memory, a RAG system first goes and looks up relevant, fresh information from an external source, like your company's private documents or a live database. Then it uses that specific information to create an answer. The key here is that this happens in real time for every single question you ask.
Now, the most basic version, which people often call naive RAG, is actually super simple. It works in 3 steps. First, you index all your data. This means you turn your documents into a special, searchable library of what are called vectors. Think of them as numerical fingerprints for ideas. This lets the AI search by meaning, not just keywords. Second, when you ask a question, the system will retrieve the most relevant little snippets from that library. And finally, it bundles your original question and that new information together and sends it to the LLM to generate a fact-checked answer. So, index, retrieve, generate. It's a really elegant and powerful idea.
But of course, that's not where the story ends. That naive RAG is really just the beginning. As developers started pushing this thing to its limits, a whole family of more advanced RAG techniques popped up. And each one is designed to handle more complex challenges and fix the weak spots of the basic model. So let's take a look at how this family tree has grown.
The first big leap forward is what we now call advanced RAG. And honestly, it's all about one thing: improving the quality of the information, the context that we feed to the model. Because we all know the old saying, right? Garbage in, garbage out. It doesn't matter how smart your AI is if you're giving it junk to work with.
So how do we improve that quality? Well, it breaks down into a few key tricks. It often starts with better chunking. That is, finding smarter ways to split up big documents so you keep related ideas together. Then you've got re-ranking, where a second, more detail-oriented model basically double-checks the first search results to pick out the absolute best of the best info. And finally, there's context optimization, which squeezes all that info down so the LLM gets just the critical facts without all the extra noise.
Okay, next up is hybrid RAG. This one is so important because it solves a really big blind spot in basic RAG. See, searching by meaning, what we call semantic search, is great for understanding general ideas, but it can be terrible with specifics, like a product number or a person's name. Hybrid search brilliantly combines that conceptual search with good old-fashioned keyword search. You really do get the best of both worlds, the context and the specifics.
And that leads us to the next massive step in this evolution: Graph RAG. Now, instead of just pulling out disconnected paragraphs of text, Graph RAG uses knowledge graphs to actually understand the relationships between things. It can see that, say, a specific person works for a certain company, and that company has an office in a particular city. This unlocks a much deeper kind of reasoning that you could never get just from retrieving plain text.
Now, all of this brings us to a really critical decision that pretty much every AI architect has to make. When you want an AI to know new things, do you use RAG to give it external facts on the fly, or do you fine-tune the model itself, basically baking that knowledge right into its brain?
This quote just cuts right through all the confusion. It is the perfect rule of thumb. You use RAG to give the model access to information that changes a lot or needs to be cited. And you use fine-tuning to teach the model a specific style, a particular tone of voice, or a consistent way of acting. They're not enemies. They're 2 different tools for 2 different jobs.
Let's break it down. With RAG, the knowledge lives outside the model, so updating it is as easy as editing a document. It's also completely auditable. You can literally point to the sentence where the AI got its information.
Fine-tuning, on the other hand, burns the knowledge into the model itself. That means every single update requires an expensive, time-consuming retraining process. It's great for shaping personality, but really risky for facts that might change tomorrow.
Okay, so the theory is all well and good, but what tools are developers actually using to build these amazing systems? Let's pop the hood and look at the essential frameworks and databases that make up the modern RAG toolkit.
So at the very foundation of any RAG system, you have a vector database. These are like super fast, hyper-organized libraries for all that vectorized information we talked about. For example, if you're just starting out and building a prototype on your laptop, Chroma is fantastic because it's so simple. But if you're working at enterprise scale, I'm talking billions of documents, you're going to need a powerhouse like Milvus. Or, hey, if you already have a big SQL setup, you can just use PG Vector. There's a tool for every job.
Then, layered on top of the database, you have the RAG frameworks. These are the orchestrators, the brains of the whole operation. And again, you pick the right tool for the right job. LangChain is kind of the Swiss Army knife for quick experiments. For industries like finance or healthcare that need really auditable, measurable results, Haystack is a top choice. And for building those really complex decision-making AI agents of the future, LangGraph is where the action is right now.
And that word, agents, points us directly to where this is all going. RAG is evolving. It's moving beyond just being a simple Q&A pipeline and becoming the core of a whole new kind of system, the autonomous AI agent.
This is the idea of agentic RAG. In this world, the AI isn't just passively sitting there waiting for your question. It's an active participant in the conversation. It can decide for itself if it needs to go look for information, what tool it should use to find it, and it can even do multiple lookups in a row to piece together the answer to a really complex problem. We're talking about a system that understands what it doesn't know and then actively goes out to learn it.
And the frontiers here are just exploding. We're now seeing multimodal RAG, where an AI can pull an answer from a chart in a PDF just as easily as it can from a paragraph of text. There are deep research agents being built that can autonomously write entire strategic reports. And with physical world RAG, we're even grounding AI in live sensor data, letting a robot use Retrieval to figure out how to navigate the room it's in. So you see, RAG is so much more than just a fact checker. It's becoming the architecture that connects autonomous AI to our reality. It's what gives these powerful systems a memory and a solid footing in the real world. And that leaves us with one heck of a final question to think about. When AI can research, reason, and verify facts all on its own, what are the truly hard problems that we'll finally be able to solve? Thanks for tuning in.